All right, this video is going to be on similar solids. So you're going to have a three-dimensional figure. It's either going to get bigger or smaller. We're going to be figuring out what the new surface area or new volume is, or what a side or an edge or a height or a radius is going to be. We're going to start off with our warm-up of reviewing with area and similar polygons. We covered this in chapter 11. Area, we need to remember our units are squared and our scale factor is squared. I like to put the scale factor squared just that way we remember we need to be squaring stuff. So again, if whatever teacher you have, if you are not one of my students, your teacher probably sets this up differently in the proportions. I like to do side over area equals side over area, because here we're going to find the area of this new trapezoid, and the reason I like to do it is because if you draw on a fraction bar equals fraction bar, you almost have your proportions set up here for you. Now when we talk about area, area is units squared, side length is not. So these inches, the ones that are in one dimension here, we need to square it to match that area. So when we set up our proportion, we're going to take the 28 squared over 500, and that'll be equal to 15.4 squared over x. I'm going to go ahead and square these numbers before I cross multiply. 28 squared is going to give us 784. And 15.4 squared is going to give us 237.16. So let's go ahead and do our cross multiplying here. 784 is now being multiplied by x. And this will be equal to, we're taking the 500, it's being multiplied by the 237.16 now. Large number, 118,580. And I'll get rid of the comma so it doesn't look like a decimal. And now we just divide and we have our new area. Divide by 784. And this area is going to be 151.25 inches squared. And make sure we have the inches squared. Also doesn't tell us what to round to. It comes out to 0.25 anyway. All right. So we move on to the solids, these three-dimensional figures. In order for them to be similar, they have to have the same type of three-dimensional figure. You can't have a pyramid and a prism. You can't have a triangular prism and a rectangular prism. They have to have the same kinds of measurements, whether it's radii, height. They've got to be proportional. So we're going to take a look at these two cubes. They have a scale factor of 2/3 from left to right. So here's your left one, here's your right one. We're going to find the ratio left to right of the side lengths. So, well, the side lengths, look, we got 3 and we got 2. So we got 3 to 2. And we're going to find the surface area of each cube. So what I'm going to do is I'm going to go ahead and look at, okay, in our surface area is going to be big P times little h plus 2 big B. So we need to find these different parts. So let's find the perimeter of the left larger one. So we add up all sides, all of them are 3, so 3 times 4, we're going to get 4. Find the perimeter of the smaller cube. We have 2, we have 4 of them, we give us 8. I don't know why I put 4, it's 12. So get 3 times 4. All right, height. Your height's going to go base to base. Okay, every single edge is going to be 3. Over here, every single edge is going to be 2. Then for big B, area of the base, we just need to take 3 times 3 to get us 9. Over here, 2 times 2 to give us 4. So with the surface area of the left cube, we're going to plug in perimeter of 12 times the height of 3 plus 2 times big B. Put this all into the calculator. We're going to wind up with 54 centimeters squared. Now the surface area of the one on the right, same thing. We're going to do perimeter of 8 times the height of 2 plus 2 big B's. So 2 times 4. We plug all of this in and we end up with 24 centimeters squared. So using this, we're going to go ahead and look at what ends up happening here with our surface area. What are the ratio of the cubes Surface areas. Well, to start off with, from left to right, we have 54 to 24. These are going to simplify. Remember, ratios, we need to simplify them all the way down. It's going to simplify to 9 times 4. And if you look at 9 and 4, 9, if you take the square root of each of these, 9 becomes 3 squared, and 4 becomes 2 squared. So just like area, exactly like area, surface area is going to be squaring your side lengths. And we'll look at that on the next page. Volume of each cube. Well, your volume was big B times little h. So with the one on the left, big B, don't have it on my page, but you should have it on yours, is going to be 9 times the height of 3. We wind up with 27 centimeters. Remember that we are at cubed now. You may start seeing what, you might already know what's going to happen. All right, with the volume of the one on the right, big B, 4, times height of 2. The volume is 8 centimeters cubed. So with the ratio of the volume, we're going to have 27 to 8. 27 to 8 cannot be reduced, cannot be simplified, and don't have the same number, can go into each of them. And we don't really talk a lot about the cube roots, but 27 is actually going to be 3 cubed. I mean 3 times 3 times 3. 8 is 2 cubed. So what we're doing with the dimensions, squared or cubed, that's what we need to do with our side lengths to match. So let's go ahead and take a look at this. When we start looking at mixed practices of the different similar solids, I cannot stress enough how much you need to pay attention to whether they're talking about surface area or volume, because don't just assume. All right, we need to make sure we identify that so we know whether we're squaring or cubing our measurements. So here we got prism A and B are similar. They have a ratio, their linear measurements is 7 to 3. If a prism has a surface area, okay, there we go, surface area. We know that we are going to square, okay, because we do have surface area. We're going to find out the surface area of prism B. So we set up our proportion. They're letting us know that the linear measurements, instead of saying, hey, this side's this much, this is our ratio. So what we're going to do is we're going to go ahead and put 7 and 3 as in our numerators, 7 squared and 3 squared. Look at the previous page right here. This is what we had, okay? And then we're going to go ahead and put the surface area. This is A, which goes with 7. So we'll have 98 down here, and here's our X. So this is exactly like the warm-up, guys. Exactly like it. 7 squared, we're going to turn to 49. 3 squared is going to turn to 9. We're going to go ahead, cross multiply, and divide. Here, 49x equals 9 times 98 is 882. And we divide, and we're done. That's all there is to it. We just have to remember to square. This ends up being 18 centimeters. It is surface area, so we need to square it. Okay? Now we're going to take a look at two similar cones that have a radii of 10 inches and 4 inches. What is the ratio of the surface area? There it is, surface area of the small cone to the surface area of the large cone. So what we need to do here is we need to first start off with a ratio. We have 10 to 4. We need to simplify this down to the smallest form, and that would be 5 to 2. Then we need to go ahead and square these. 5 squared, because we're going from the radii to surface area. So we have to take the radii and square them, just like in our warm-up where we had to take the side lengths and square them. This ends up being 25 to 4. Now be careful, this is not our answer. They want the ratio of small to large. So we want S to L. So even if you don't remember, oh, which was the small, which was the large? The smallest number, 4, to the largest number of 25. All right, last one. We've got containers that are similar cylinders. Find the height of the smaller cylinder, round to the nearest tenth. What we need to see here is that they didn't say it in the problem, but right here we have V equals. That means we are dealing with volume. And as we saw on the last problem, the last page, volume we need to cube. So let's set up our ratio, our proportions, sorry. Now, unlike the warm-up, these side lines, these heights need to be cubed. So we're going to have H cubed over its volume of 270 pi. Don't forget that pi symbol, please. We're going to need that later. And this will be equal to, so again, here's your proportion. 10 cubed over 640 pi. The first thing we need to do is cube the 10 squared. Or not, we need to cube it. So in your calculators at school, how we're going to cube a number is we're going to plug in the number, we're cubing 10, plug in 10, and then over here, underneath the control button where the control button and the 4 meet, you're going to see this little caret right next to the x squared. You're going to press that. It'll take you up to the exponent place here, and we're just going to type in the 3. And there we go. We press enter and we get 1,000. So now what we'll do is we're going to keep everything exact in terms of pi until the very end. When we start cross multiplying here, we're going to have h cubed times 640 pi. So we'll just put down 640 pi h cubed. Please don't forget the 3, and don't forget it is a 3. Now we cross multiply the other cross product here. We're just going to do 270 times 1,000, and we're going to keep that pi symbol on there. And so 270,000 comes out to, the 270 times 1,000 is going to come out to 270,000, and throw that pi symbol. Just as if this h was just an h, or an h squared, we need to go ahead and divide both sides by 640 pi. The 640 pi will cancel on the left, leaving you h cubed, and then the pi's cancel on the right. And we take 270,000 divided by 640, we're going to wind up with 421.9. Now we need to do the cubed root. When we do the cubed root, what it looks like is we're going to have this little index of 3 right here. We're going to do the same thing to the other side. In the calculator, what we're going to do is, just like when we take the square root, we push Control X squared, we're going to push Control and then that little caret thing that took us to do the exponent. So we're going to press Control and that little caret button, and here we can type in what index we want, which is 3, and we could scroll over, and then we could type in that 421.9. Press Enter, and we're going to wind up with 7.5. And because this is a height, it is one-dimensional, it's just going to be inches.